Okay, this video is looking at solids and Euler's rule. So when we talk about solids, what we're really talking about are three-dimensional shapes. Okay, and the name for those are polyhedra or polyhedron. Polyhedra is the plural of polyhedron. So a polyhedron is a closed solid with flat surfaces, which we call faces, vertices, which are the corners of a polyhedra, the vertex, and edges, which are the sides that are joining the vertices together. We can name a polyhedra by their number of faces, so this is one way to name them. This would be called a tetrahedron, and it's a four-sided polyhedron. This is a six-sided, so the prefix for 6 is hexa, so we've got hexahedron. And this one we've got a five-sided shape, which is a pentahedron. Okay, and that's not, I don't think it's the most common way to name these. I'd say the first one, a tetrahedron, that's pretty common. The second one you'd probably call a cube, and the third one you'd probably call a square-based pyramid. But we're going to look at some other names for 3D shapes in a second. Okay, we're going to take a look at Euler's rule, and Euler is a famous mathematician, and I know that word looks like Euler, but it's actually pronounced Euler. And Euler's rule is a rule that connects the number of faces, vertices, and edges in each polyhedron. So we're going to see if we can discover this rule. So for each of these polyhedron, I want you to take a look and write down how many faces, how many vertices, and how many edges each have. And like always, you can try and do this on your own. So if you want to stop the video now, you can fill in this table. Otherwise, you can follow along with me. So this first one here, we've got 4 faces. And in terms of vertices, we've got 1 at the top there, and then 1, 2, 3 at the bottom. So we've got 4 vertices. And edges, we've got 1, 2, 3, 4, 5, 6 edges. Okay? Second one, we've got the cube shape there, so that has 6 faces. Vertices, we've got 1, 2, 3, 4 on the top and 4 on the bottom, so 8 vertices. And then we have got our edges, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. Okay, we've got, in our third shape, we've got 5 faces, so 4 triangular sides and then a square at the bottom. In terms of vertices, we've got 1 at the top and 4 on the bottom, so we've got 5 vertices. And edges, we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. And our last shape, we've got a pentagonal prism, so we have got a pentagon shape there as a face. So that has got 7 faces because it'll have 2 of the pentagons and then 5 rectangles on the side, so 7 faces. Vertices, we've got 5 on this face, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, so 10 vertices. And edges, we've got 5 on the front pentagon, 5 on the back pentagon, so that's 10, and then 5 connecting each of those together. So we've got 15 edges altogether. And your task or your sort of challenge is to see if you can find a rule connecting the number of faces with the number of vertices and the number of edges. And we're going to do it in terms of edges, so you're going to have the number of edges equal to something else. And I'm going to leave you with that, and we're going to discuss our results in class. So see if you can find a rule that ties together the number of faces, the number of vertices, and the number of edges. Okay, we're just going to take another look at naming our different polyhedra. So we're going to look at prisms first, and prisms are polyhedra with 2 identical ends, so 2 identical. And we learned the word for identical in another section that was congruent ends. So you can see in this first one the 2 congruent ends are octagons. And then the other sides are rectangles. Okay, and these are named in terms of their congruent ends. So in this case, we have an octagonal prism. Okay, this one here, you can see again, I've got two congruent ends. That would be those triangles there. And then do you see the sides of this are three rectangles. So that's a prism, because I've got two congruent ends and rectangular sides. And that would be a triangular prism, because the two congruent ends are triangles. Okay, another type of shape we have, or another type of 3D shape we have, are pyramids. And pyramids have a base that is a shape, some sort of polygon, and then the other sides come together to form a point at the top. Okay, and so we've got one base, which is, you know, could be a square, or in this case of the second one, it's a hexagon, and then we've got triangular sides. Okay, so that's what a pyramid is. And these are named in terms of their base. So in this first one, we have a square-based pyramid. And actually, I'm not quite sure if that's a square or a rectangle, so it may be a rectangular-based pyramid, actually. Okay, because we're not quite sure that all the sides there are equal. And in this one here, we would have a hexagon-based pyramid. So whenever we're naming pyramids and prisms, we're always looking at the sort of shape of it to give it the name, and then we kind of stick pyramid or prism on at the end. Okay, we've got some special 3D shapes that have curved surfaces. This one here is called a cone, where we've got a circle as the base, and that just looks like an ice cream cone upside down. We have a sphere, which is just like a ball. Sorry, I've spelled that wrong. Sphere, S-P-H-E-R-E. Was looking at it, looked a little bit weird. And the last one here is a cylinder, and often we see cylinders in sort of food packaging and cans and things like that. And then we've got two special prisms. This one here, where we've got all 6 sides are squares, is a cube. And if we have something that looks like a cube, but actually we've got 4 sides that are the same and then 2 other sides, then this is called a cuboid. Okay, so a cube is like a 3D square and a cuboid is like a 3D rectangle. Okay, so that's our lesson on different 3D shapes. So if you want to give a summary, and maybe in your summary you can describe what you did to try and work out Euler's rule and the difference between pyramids and prisms. And then you can write your question here for class time.